In this video, we will learn about 3D equilibrium of particles, topic 3.4 from chapter 3. This is the theory portion of the video. Three-dimensional force systems. Objectives: draw a 3D free body diagram and apply the three scalar equations of equilibrium. Quiz. Particle P is in equilibrium with 5 forces acting on it in 3D space. How many scalar equations of equilibrium can be written for point P? We have studied that in 2 dimensions space, for any free body diagram, we can write up to 2 scalar equations. Sum of forces in x equal to 0, sum of forces along y direction equal to 0. So for 3 dimension, we have one more equation, that is sum of forces in z direction equal to 0. So the correct answer is 3. When a particle is in 3D equilibrium, which one of the following equations are applied? Sum of forces along x, y, and z equals 0. Sum of all the vector forces equal to 0. Or scalar equation, sum of forces in x equal to 0, y equal to 0, or z equal to 0. The correct answer is all of them, because all these equations can be applied. Application. You know the weight of the electromagnet and its load, but you need to know the forces in the chains to see if it is a safe assembly. How would you do this? So in this example, we will draw a 3-dimension force system by drawing a free body diagram for A and indicate the forces in this chain. Force 1 direction, chain, 3rd chain, and 4th chain, and then also force in the hook. And by drawing this free body diagram in 3D, we can apply 3-dimension equations of equilibrium. Okay, so as shown in the figure here. So that's the free body diagram. The sheared leg derrick is to be designed to lift a maximum of 200 kg of fish. How would you find the effect of different offset distances on the forces in the cables and derrick legs? So this is being supported at B. So if we draw a free body diagram of B, then we will have one force here, second force here, third force in the cable, and fourth force is because of the weight of the faces. And then by drawing free body diagram for B in 3-dimension space and by applying equations of equilibrium, we can answer this question. So if particle is in 3 dimension, we have x, y, and z axis. And if there are 3-dimension forces such as F1, F2, and F3, then if the system is in equilibrium, if this point is in equilibrium, then we can say that sum of all the vector forces is 0. And then from this one vector equation, we can actually separate this into 3 scalar equations. Sum of forces in x equal to 0, sum of forces in y equal to 0, and sum of forces in z equal to 0. Okay, so these are our 3 equations of equilibrium, 1, 2, and 3. And using these 3 scalar equations, we can solve for up to 3 unknowns for a given free body diagram. Okay, and this is the example part of it. We will see that in the next video. Thank you.